Right, good evening, boys and girls, how are you? Right, today we want to start with a new topic on interpenetration and development. Right, specifically we want to look at offset combination. Right, I'm going to explain those terms in detail. So I want you to pay attention so that you understand what is offset, what is inline combination, and so forth. Right, okay, like we are talking about interpenetration and development. Right, you'd find that in most cases we've got pipes that are combined, okay? So if there's one pipe which is coming from the left and the other pipe which is upright, those pipes, if they are to transmit or provide a leeway or a passage, say for fluids, water, or gas, they need to be sealed, okay? So there should be a mechanism to make sure that the two pipes are connected properly together. And when they do that, right, we refer to that process as interpenetration, right? But before you look at the interpenetration, right, you need also to look at the pattern that you would develop, okay? Or you would come up in order to join those pipes together. Right, that's why you find that we talk about interpenetration and development, okay? The development, when the pipe has been laid out, maybe in form of just material, and it's cut according to the size and according to the profile that has to be folded, that is what we refer to as the development, okay? Right, so in drawing terms, we would also look at such terms as inline combination. Right, when the center line or the line of symmetry for one pipe is basically in line with the line of axis or the line of symmetry or the center line of the other, that's what we refer to as inline combination. I would show you graphically when we start our presentation, but for now, that is just the explanation that I can give. Right, now we have got what we refer to as offset combination. Right, with regards to offset combination, you would find that the center line or the axis line, they do not share a common center line. And in that way, we refer to that one as offset, okay? Then we have got the line of connection between the two pipes. There could be two pipes, there could be any geometric solids which are put together or joined together, right? If the connection line would result in a curve, right, we refer to that one as a curve of intersection. But if it is a straight line, we refer to that one as a line of intersection. Now, once we have defined the line of intersection or the curve of intersection, you then need to come up with the pattern, right, which we refer to as the surface development, okay? Right. This would be more like a template that can be used for mass production of things. So when we get to the real work, we are going to look at the given top view. We are also going to look at completing the front view by determining the line of intersection. We are also going to look at surface development, that is the main pipe, and the branch pipe. The main pipe, in most cases, you find it will be the vertical pipe, and the branch pipe would be coming from the side. This could be at an angle, or it could be perpendicular, or at 90 degrees. We are also going to look at details, labels, details in terms of visibility, and the labels which are associated with those developments that we talked about. And we are also going to show you the necessary constructions which are key in coming up with a development and the curve or line of intersection. So enjoy the lesson, boys and girls. Remember, you should be able to do it on your own to show understanding. So I urge you, everyone, to make sure that whatever we are doing right here, you take your drawing board, you take a piece of paper, sit down and try also to come up or to do exactly what we are doing here. That way you would enhance your understanding with regards to the lesson, okay? Or to the topic that we are doing right now. Thank you. Enjoy the lesson. Right, okay. Let me just push this one so that we are able to see clearly. Right, bring this one down. Right, we have got the given information, right? The given figure, it's here at the bottom, right? I shall show you later on, but let me just read so that you are able to understand, okay? Right, the given figure shows the incomplete front view and top view of a right regular square prism that penetrates a right regular square prism. The axes of both prisms do not lie in a common vertical plane, right? There is a misprint there because if you check on this one, right, that is what I was just explaining. You'd find that the center line for this one and the center line for that one, they do not lie in the same horizontal line, okay? That way, you'd find that they do not lie in the same, they are not in line, okay? And this is a typical example of what we refer to as offset combination. Right, we are also given point A, right, which is our starting point, point A, right? If we check on this one, you have that point A there, okay? Right, draw to scale 1:1 and in first angle orthographic projection, the following views of the two prisms. The top view using point A as a reference point, right? If you check, we have got our top view, right, like this. This is our top view. So we are supposed to copy this using point A as our reference point. Right, the complete front view. When they talk about the complete front view, if you check, there are certain lines which have not been drawn. Right, so what we require is to come up with the line of intersection, since this is a straight-sided shape. Right, when we are looking at the top, this is basically the line of connection between this one, which we refer to as the branch pipe, and this one, which we refer to as the main pipe. So on the top view, the line of connection is already there, which we refer to as the line of intersection, okay? Right, so, but we also need now to establish the line of intersection with regards to the front view. Construct the surface development of both the main pipe and the branch pipe. We shall look at that if we spread out the two geometric solids after they have been connected and sealed, right? We need now to know what sort of material will be required for the two components to be connected together and form one entity, okay? Label both surface development, we shall look at the labeling, show all necessary constructions, and show all hidden detail. Right, one key characteristic that we find with regards to offset combination is that there has to be hidden details because you are not going to see the other details in terms of the other sign. When it is in line combination, you would find that the details fall basically in line. The detail which is in front is basically the same as the detail which is at the back, okay? But the moment you are able to see that there are certain details which you are not able to see, which are at the back, that is a typical offset combination, okay? So now we want to start the drawing, looking at this setup, right, like this. Right, so we are supposed to copy this. Right, what I would urge you to do first, you draw faint line like that, a faint line, right, and another faint line like this. Right, let it go like that. Right, okay, I'm sure it's clear, right, in terms of our presentation. Okay, so this is point A, which is point A. Right, when a square is sitting at a corner like that, I think I showed you when we were looking at solids, you draw a line, a faint line like that. Right, you draw a faint line like this, right? Then you measure half the side. Half the side in this case would be equal to, right, 34 is the overall side, okay? So half of that one would be 17. So I'm going to measure 17 here. 34 divided by 2, which is your 17. You mark a point like that. Right. Once you have marked that, you now take a 45 degrees set square, draw a line, like this. There you go. Right, so that is the square that has been drawn in position. There's nothing that would stop us from outlining this. If you measure from here to there, you'd find that it is 34. From here to there also it is 34, okay? Right? Just want to make sure that you are able to see the picture as well as the question itself, okay? Right, so from here to there, that's 34. From here to there, that's 34. Right, let's just verify. There you go, okay? Which is perfectly 34. Right, and you can outline this. From here to there, that's the face. Like that. Right, this is an introduction to what we will be doing with regards to the interpenetrations and development. So I want you to pay attention so that you understand fully what we are doing right now, okay? Right, the next thing that we want to look at now, having drawn this one, right, we can now just measure from here to there about 10 millimeters, it's fine. Then define the ground line. So let's measure here. Don't take it too high because you would need to position the developments, okay? Right, so I'm going to draw this like that. Right, and I would label this one X and Y. This is the ground line, okay? Right, from there, you look at the size from here to there, that's 60. Right, I'm going to measure from here to there, 60. Like this. Like that, okay? Nicely. Right, then the next thing that you would require, if you check on this diagram, right, after measuring your 60, right, from here to there, that's 60, then there's an 8 millimeter, right, which would come handy later on, right? So I want to measure that 8 millimeter and project like that, and project like this, right? Then from there, I can project from this, right, the top view, right, in terms of the square, right, project this one up faintly like that, okay? Right, if you check the distance from here to there, or that line from here to there, it's not going to change, right? Because it's not interfering with the connecting pine. So I'll outline it. Right, the same applies with this one. Sorry about this. Okay, right, Normally don't want those double lines. Right, so from here to there and from here to there, that's the way it is. Right, then at this point, which is that point, okay, right, I draw a line at 45 degrees. Draw a line at 45 degrees like that. Right, then where it meets this line, I draw again at 45 degrees the other way, like that, okay? Right. Now, once you have done this, the next thing that you want to do is to construct the auxiliary view such that you'll be able to project backwards that side, okay? Right, so you can just start from somewhere. You would find, I can just start here. Right, that is my upper part. Then this corner is in line with that corner. Right, and what is the size of the auxiliary view? Is 20 millimeters. Right, then you measure 20. Right. Take this one, right, just to verify. There you go, okay. Right, if it is a square, there is no need to, I can miter like this, like that. Make this one slightly darker than a construction line so that you are able to see. Like that, okay? Right, so that is the auxiliary view in position, okay? Sort of tilted a bit, doesn't show, yeah, okay. Right, in terms of, right, let me just concentrate on this one. Right, so we have got this, which is this point, which is like that. Then I project from here, faintly, okay, like that. Now I can label this point 1, this one 2, this one 3, and this one 4, like that. And I can come here and label this one A, small letter A, this is B, this is C, and this is D. Right, okay. Right, so I've got A, B, C, and D, okay? Right, these are the points with regards to the main pipe, which again is a square prism. This one is for the square prism, but it is the branch pipe. Right, so what it means is that when I'm doing this, I can also outline from here to there. That line can be outlined, and I can bring this one all the way like that, and bring this one also like that, okay? Right, it's not yet defined, but it's the information which is there. Bring this one also here, like that, and close at the top, like that, and also at the bottom. There you go, okay? Right, unfortunately, I cannot erase this one because I'm using a pen, but it shouldn't be like that in terms of that line, okay? Right, so this is the front view that we have. So the next thing that we want to do is to position this other view. If we check, okay, you'd find that the other branch is seen from the top view, right? It is slightly offset, okay? So this is not in line with that. By how many millimeters? By 5 millimeters, okay? So if we go back here, right? We measure from here to there, right? 5 millimeters, and we draw a faint line like that, right? Now, just define the end part of this one. You bring this one down, right? Thereafter, you can project and do this. Right, you also need to draw this auxiliary view, right, now related to the top view, okay? So I've drawn a line like that, but this will be turned upside down, okay? So if we turn this point, number 1 will be here, number 2, number 3, and number 4. Right, what is the size? It's 20, so I measure 10 millimeters. Then, like that. Right, there is no need to really outline the auxiliary view like we did there, but just to make sure that you are able to show, especially when we are learning, still learning like this. Right, I can just make it slightly darker. Okay. All right, so we have got point number 1. Turn that point number 1 through 90 degrees. You'll find that this point number 1 would be here. So once point 1 is here, this would push point number 2, point number 3, and point number 4, like that. Right, then project now. Project to hit the main pipe, like that. Now, once these projectors hit the main pipes, if you take them up and coordinating with those ones that are coming from the auxiliary view in the front view, you should be able to plot the points that would define what we refer to as the line of intersection. But before you do that, the first thing that you may also want to do is to complete the top view. So I'm going to do this. Right, as long as the view is seen at an angle, right, you are able to see this surface. So it won't be a straight line like that. So if we take point 1, take it down, and point 1 would be here, okay? Right, then from there, if you take point 2, hitting this surface, bringing down, right, point 2 would be there, okay? Right, the same applies 3, they hit this surface and take it down, and point 3 would be there. So if you are used to this, you find that once your projections are correct there, 1, 2, 3, and 4, right, you can easily join those points. Like that. There you go. Right. Now, if you check, right, in terms of the presentation, you'd find that you are also going to come up with this square, right, which looks more like a rhombus, right? Now, you can outline this because you are able to see all these details, so you can outline. One point of connection between the branch state, copy the given view. So there are quite a number of constructions that need to be done, okay, in order for you to come up with the top view like that. And that's what we have been doing just right now. Right, so you can then outline from here to there, right, from here to there, and finally this, like that, okay? Right, but if you are looking from the top like this, right, you won't be able to see this line, right, which is line 3 and 3. 1, 1 is seen. So if I were to label here, I would say this is point 1, this is point 1 as well, okay? Just for our discussion purposes only, okay? Right, remember, like I said, sometimes there's no need for you to label anything, but it will come handy, okay? Right, so if you are not going to see this edge and you know it is there, you represent that edge by way of a hidden detail. So I'm going to define this one as a hidden detail like that. Right, that way we have now copied the given top view. as it is. Right, once we have this information, the next thing now is to come here and now work on completing the front view. Right, now from here we say this is 0.2, this is 0.2. This is just for illustration purposes. Right, so when you are looking from this side, remember, if it is in first angle orthographic projection, what you see when you are looking from here is what would be defined here as our front view. What you see when you're looking from the top is what is defined here as our top view. So the line of intersection, right, is seen from the top, is already there, okay? Right, so if you are looking from this side with regards to the branch pipe, you are definite to see line 2, 2, okay? Right, so what we need to do is to project this like that, okay? Right, and then project from there up until it meets this. So we now have got another a 0.2. This is 0.2, which is here. This is also 0.2, which is there, okay? Right, the next thing that you will be able to see, maybe we should have started with 1, 1, right? You do the same thing, right? This should be projected up like that, and it should meet line 1, 1. Right, so let's project and extend this. Right, so there is our 0.1, there is our 0.3. Right, then you have got point number 4, you project this one. Right, 0.4 from here, there is our 0.4. But there are certain things that we want to establish, okay? Right, when we are looking from here to 2, there's nothing that would stop you from seeing the whole line 2, 2. So I'm going to outline from here up until we get to this point, right? Even before I join, this is my obvious line, right? And if you look at this 0.11 or line 11, it's on this side of point A, right? I shall come back to point A, so we can extend from here to there. That's the same thing also on the underside. We can also extend this one to here, right? And extend this one to there, like that, okay. Now, let's look at the combination in terms of joining. From 1, you go to point number 2, we can connect this. Point 1 to point number 2, faintly, let's not outline at this point. Then from 2, you go back, but on the lower side to point number 3. Right? Like that, okay? Now, from point number 3, we need to go to point number 4. Remember, this is 4 and this is 4. It's a prism. Right, from point 3 here, we need to go to point number 4. But see something here, right? You are not going to go there straight from here to there. You need to pass through this point, right? And at that point, for now, it has no name, okay? So what you do in situations like this, right, you give this one a name. You can say this is X and Y, okay? X at the top and Y at the bottom, right? So the moment you relate this one, right, it's either it's point X or it's X or it's point Y. Let's do this. Right, I want you to project this one backwards, like that, okay? Right, if you go back to the auxiliary view or even to this part, okay? Right, you would find that this one, let's call it point X, this one, let's call it point what? Y. So by projection from this point, when it hits the auxiliary view, the first part you call it X, it's between 1 and 4. The second part you call it Y, between 3 and 4, okay? Right, and this should also be represented in terms of that information on the other auxiliary view. So you take this distance here, right, from 4 to X. Look for point 4, which is here, like that, and mark off, like that. What point do we establish? We have established point X. So if we project this one down, right, we should still be able to get this X right, which is coming from here, and this X, they should meet somewhere, okay? Right, if you check, the same distance would prevail from 4 to Y, okay? Right, standing at point 4, like this, then opening your canvas to point Y, towards point number 3, like that. We establish another point, we refer to this point as Y, okay? Right, you would realize that once you get one like that, you could even just draw a line like this, okay? It's one and the same thing. But you can also get this point, right, by projecting from here, where you would cut this side, right, which you are able to see when you are looking from the top. If you project like this, right, if you are accurate, you'd find that by projection from this other end, it will be one and the same line like that. So there are two ways. It's either you project it to hit this line, then you project it up to hit this surface, then you take it downwards like that, or you project this point to hit this, then you take the distance between 1 and 4, 1 and 4, right, which is your point X, okay? Right, so if you also do the same by projecting from here, like that, then you take it to this other point, you'd find that it will basically be one and the same point, but of course it will depend with your accuracy and so forth, okay? Right, so now let's look at this. This is line X, right, which is now on the other side. We are looking at where this prism is meeting the branch prism, right, in terms of the surface. So it will be on the other side of this ridge line, okay? Right, so if we take this one, right, we mark a point like that. This is our point X, okay? If we take this one and project this one will be our point Y. Right, but because it's on the other side, the line from here to there has to be hidden. The line from here to there has to be hidden, okay? So I'm going to extend this and define it as a hidden detail line like that, right? The same applies with this one as a hidden detail like that. Okay. Right. So what happened is we started point 1, we to point number 2 to number 3. Number 3, right? If we as here we go to point so 3 to 1, okay? Before you go to point 4, okay? Right. So I want to connect this. You go to point X, right? Which is this X. But from X, you come to a certain position, which is your point today. These are the lines from here to point Y, from Y to point 4, 4 to X, X to 1. They are now hidden. So we can come here in terms of our information or our question that we have to answer, right? Draw the top view using point A as a reference point. I want you always to do this, okay? But tick, this I have done, okay? Right, the complete front view. When you have defined everything like this, you have completed the front view, that's fine. Right, the next thing that you want to look at is to construct the surface development of both the main pipe and the branch pipe. The surface development of both the main pipe and the branch pipe. And this is how you do it, okay? Right, you have got the front view, you have got the top view. Right, you just mark a point. I can take this one as my first point. right? In most cases, right, try to open through. If you are not given the seam, try to open through, right, a part which would be shorter in terms of welding or sealing, okay? Right, remember in industry, they talk about time being money, okay? You don't want to waste a lot of time welding from here or joining from here to there when you can just join here and join there, okay? All right, so where possible, just try and open through the shortest part so that you save on time, you save on resources as well. Right, this point is point A, but it's not going to stand as just point A because there are certain attachments to it. So wherever we have got point A, we have got point X and Y, okay? Right, then you take your compass like this. Take the distance from A to B, like that, A to B, right, which is actually 34. You step, this is point B, right? This is point C and D, right? Then you need to come back to point A, like that. So we are going to label, this is B, this is C, this is D, back to point A. But A, like I said, is represented by X and Y, such that if we are projecting from there, we should be able to see that. You raise these lines up. Like that, okay? Now, let's start by defining the X and the Y, okay? Right, here we've got an X, we also have got a Y, here we've got an X, we also have got a Y. So if you project from here, like that, the first one, this will be our point X, and this will be our point X as well, okay? Right, and we project from here, like that. This will be our point Y, this will be our point Y. Right, so we have got point X and we have got point Y in position. Right, the next thing that you need to define is now where lies the connection between point 1 and point 2, between the branch pipe and the main pipe. This is what you do. Right, from point A towards point B, there is point 4, okay? So you take it from this. You take directly from the top view. This is the true distance. Right, from A towards point B, from A to B, right, lies point number 4. So you describe that, you mark that. So you label this one nicely, that's point number 4. You project this one up faintly, like that. Then from point A towards point D, right, you have got point 1, which is the same also as point number 3. But I can make this one easier by taking the distance from D to 1, all right, like that. Take the distance from D to 1, right, go and stand at D like this and mark. This is point 1 and point 3 because they are in line, okay? Right? I can now stand at point A, open to point 2, like this, right? You stand at point A towards D and mark off 2. So you stand at point A, like this, then define point 2. So that's our point 2, like that. Right, then you project these ones up faintly, right? You project them faintly like that. Now, once you have done that, you can now project these lines, right? Let me start with one at the top, like that, right? So there is my point number 1, okay? Right, then from there, I go to point number 2, right? There is my point number 2. From there, I work number 3, which is in line with point number 1. Right, there is the point 3 in terms of cutting the main pipe. Right, From there, I now project number 4, which is here, right? Point number 4 would be there, okay? Right, so I've got 1, 2, 3, and 4. Those points are now defined, right? Point 1 is connected to pole number, right, to X, right? This is the opening part, so it's 1, 2, 3, right? 1, then we have got 1, X, 4, and Y, okay? Right, there is the connection between this one and that, so let's do that. We're going to do that faintly, right, from there to number 2 and 3. Back to 1. Okay, right, if I were to go here, right, it's Y, 4, like that. Okay, right, now we can outline, right? Remember when we're looking at solids, we would say once you have defined the shape that has been cut, outline that and you hatch it. Once you have defined the part that has been cut, outline and define that one as well, okay? Right, so I'm going to outline from here to there. There you go. Right, that is part of the opening, all right? And you come here as well. Okay, then the rest, in terms of this prism, you can outline this is not disturbed at all. This part is not disturbed at all. And you do the same this side and that side, okay? Right, you can close at the top. Remember, the opening could be right in the middle, right? It depends on where you want to open through, okay? Right, you do that. Right, so now you have got this, but it's not complete. We still need to find the fold lines, right? We are going to fold through point B. I can show these ones with dotted lines, not hidden detail, but in this case, now these are basically dotted lines. Right, I can also fold through point C, right, and through point D. Like that. Now, you have got these other lines that you created in order for you to come up with a point of cutting or a line of cutting. Right, you can make these lines different to the normal fold lines that you have created. You can make them just slightly solid, but not as dark as the outline, okay? Right from the bottom to the top. Markers would want to see these lines, right? And these lines are also credited with marks as well, okay? Right, they could be center line like, remember they are not center line, but they may appear as center lines, right? They could, these ones could be here and these ones there, it doesn't matter, okay? So this is what you have. Then you will write at the bottom, development, right? I'm not going to write everything. Main pipe. That is the development of the main pipe, right? So if we fold these, right, and we cut here, just the way it is drawn, right, and then we come up with the development of the branch pipe, we fold it again through the fold lines, right, and put everything together, you'd find that you will have a perfect combination, right? Perfect combination in terms of, right, in terms of the joining line. So that is what we refer to as the line of intersection. Right, in some cases, you find that this pipe would get through this end and on out through the other end. Right, that can also be referred to as interpenetration because it's getting through like that. Okay, right. If they are just meeting, that's intersection. If one is going all the way through, it's interpenetrating. Okay. Right, now that we have got this with regards to our main pipe, right, we now want to also draw this one, which is the branch pipe in terms of the development. If you have got space, let me just take this one up a little bit, right? Right, if you have got space, right, at the top like that, remember it's always projected in line with the base like this, right? So do not draw it vertically like that if you want to use the same points by projection. But I'm going to show you the other method when you are not necessarily projecting like this. Right, so you have got a starting position, right? I can mark this point like that, okay? Right, I'm going to label this one to be my point 1, which is this point, right? So I'm going to unroll this one, but also now taking into considerations those points of intersection, right? Take this, which is your site, take it from the auxiliary view, stand how many times or step how many times? That's point number 2, 3, 4, 5, right? It's a space, so after 4 we go to point number 1, okay? Right, so I'm going to say this is point number 2, this is point number 3, this is 4, and back to 1. If you open through point 1, you end at point 1, just like we opened through point A, we ended at point A, right? Then you draw lines faintly. Right, okay. Now, once you have done that, you now project from this point parallel to the baseline like this, right? This would be 1, right? Then you go there, you have got point number 2, you have got point 3, you have got point 4. You are not going to leave out X and Y. This is Y, this is X, like that, okay? Right, so we have got from here to there, that's 1 and 1, okay? Which is the same as that one as well, because it's 1 and 1, right? Then from there, we also need to establish point X and point Y. This is what you do. You go back to your auxiliary view, take the distance between 4 and 1, like this, right? Look for point 4, you stand there towards point 1, you mark like that. But what point did I establish? It's point X, okay? Right, stand at point 4 and open to point Y, right, towards point number 3, you mark like that. This is point 1, okay? You project these lines as well, faintly, like that. Right, so I've got 1, 1, right, from 1, I go to point number 2, which is here. From 2, that's number 3, which is there. From 3, I go to point Y, right, which is here. Right, from Y, I go to point number 4, I rise a bit, which is here. From 4, I go to point X, okay, which is right here at the bottom. From X, I go to point 1, okay? So you connect these points. Right. 1 to X. Three to 2. Then 2 back to point number 1, like that. Right, if you are satisfied that you have done the right thing, right? You can now outline this. Start by outlining or defining the point of cutting. Into one. And then there you go. Okay. Right. I can now outline the rest. And also the baseline. You can also define the fold lines through the normal fold lines. 4 to 3, then 2. So this is the pattern that you would need to cut in order to combine with this pattern. So if the two patterns are combined, they would form a joint, and that joint is defined by what we refer to as the line of intersection. Right. Like I said, these ones, you can just make them slightly darker than construction line because they are defined. Okay. Right. Then you write nicely development branch pipe. That's the development of the branch pipe. Right. So if you look at this now, this is now the complete question that we needed to look at. Right. The complete question, right, in terms of the development and the development, the front view, right, as well as the top view. Right. We also defined the auxiliary views as given like this. So, right, in the next exercise that we are going to look at, you'll find that we may not have space to draw this, okay? All right, we may draw it somewhere separate, okay? But for now, because we were able to project directly from the front view like this, right, we'll leave it like this, okay? So boys and girls, right, this was just the introductory part. When we meet again tomorrow, I'm going to come up or work on slightly more challenging, right, exercise in terms of interpenetration and development. Right, I hope you grasp the concept with regards to interpenetration and development, and hope to see you tomorrow again. Thank you and good night.